Hey, Keith, let's go ahead.
Okay.
We're going to cover a little bit today about what to do when your software doesn't know how to give you the answers you need. We want a way to be able to go back to raw data. We want to be able to look down at what's coming off the wire to verify what we're seeing, to contradict what we're seeing, to explain what we're seeing. In some cases, you've got a tool or firewall or some type of network monitoring system that's giving you answers that just don't make sense. So, how do you get better detail from a lower level? We've given presentations on going all the way down to the packets themselves, to running, looking at packet files, looking at interfaces, and that is absolutely a reasonable way to do this. But we may not always have that. So there's a middle ground between the low level packet and the high level analysis tool that we have, and that's the Zeek logs. Zeek takes those packets and gives us summaries of the connections that are coming by and the details that are being asked. And we can use that to get more detail on what we're seeing and maybe explain why something is happening. Keith and I will be going through this today. We wanted to give you two different approaches to mining your Zeek data. I'm going to talk a little bit more about the manual approach, and Keith will be talking about some of the high level stuff that makes this a whole lot easier. We'll give a little bit of credit later on to another colleague of ours that wrote one of the toolkits. We'll find out more about that in a few minutes. I want to start with command line tools. And for some of you, this is a little bit odd. For some of you, you've been writing shell scripts and running command lines forever. Doesn't matter where your experience level is. The beautiful part is that you don't need to have a whole lot of background to be able to pull useful information out. So we're going to start off with the idea that you need to get over to where your logs are. These are usually on the Zeek sensor itself. You'll need to log into that, usually over SSH, but on the console is just fine too. Then you need to go to the directory that's holding your logs. Now, this is one of those things where there isn't one directory. There's not a standard. So you may have to look around a little bit. If you try the first command saying, let's go to yesterday's logs for under opzeek logs, and it says, hey, that directory doesn't exist, no problem. Use the next command, the find command, to say, I want to look through the entire hard drive. Tell me where you find something called con.asterisk.log.gz. That'll tell you probably where those logs are. And you can do, anytime I talk about opzeek logs, go ahead and use that on your system. Then if you look in that directory with the ls command, which is like the directory command on Windows, you'll be able to see what logs are there. And this will just give you the top 10 entries from there so you can make sure you have those logs. One thing that happens with Zeek is that it doesn't want to take up all your drive space with these network connection summaries. So it will compress them, save them to disk, a little bit like using zip on Windows. We use a tool called gzip on Linux. And to tell that a file has been gzipped, the extension is .gz. So normally you'd have to go and move these files to a temporary directory after you've created that temporary directory, uncompress them, do your searches, and then delete the uncompressed versions or recompress them if you move them out of the original. That's a lot of steps. So there's a convenience feature in Unix where if you add the letter Z in front of the command that you want to run, it will actually decompress them for you, do the task you want it to do, and then delete the temporary file on the way out. So let's look at an example. If I want to look at a file that's uncompressed, I'll use the less command. This is like more in Windows or more in Unix, actually. But if that file is compressed, I simply add the letter Z in front of it. That will decompress the file to a temporary file, show you the temporary file, and then delete it on the way out. If I want to use the grep command to look for text inside a file, I can use zgrep to say, uncompress it to a temporary file, look for that text, and then delete it on the way out. Same with cat, which is like the type command on Windows. I can use Zcat to say, decompress this stuff and then give me all of that text that I can feed into some future command. So if you're not sure if it's available, just type the command you want to use and put a Z in front of it. If it says bad command or file name, then it's not there. So here's an example. I want to look at a file called con.0:00:0021. These are the logs for connections between midnight and 1 a.m. They're log files, and they've been compressed with gzip. So if I want to look at the first one, I can type zless space dash capital S, and then the name of that file. The dash capital S says don't line wrap. Just give me the first 80 characters or however wide my console is. Just show me that. And if you'll note down at the bottom where I show you an example of this, I see the text in that file, and then there are arrows over to the right saying, hey, there's more on the right if you ever want to take a look. And now I can use the arrow keys left and right to scroll left and right through my text, as well as up and down through the file. So here's an example of where I want to look for all entries for a given IP address. Let's say that I'm working with a threat hunting package that has said, hey, 10.0.0.238 is doing weird stuff or malicious stuff or transferring a huge amount of data or anything else. You want to go back and confirm this and see if there's more detail that you can pull out of the logs. Let's give that a try. So the format for that is zgrep space, the IP address, hold on to that for just a minute, con.asterisk.log.gz. So I say what I want to look for, and then after that on the command line, I give the name of the files I care about. After that, I take that output and I feed it to that same less dash capital S command saying, I don't want this to just scroll up the screen where I can't work with it. Let's feed this into something where I can scroll up and down as needed. Now, the odd part is the IP address format. What I've done is I put backslashes in front of each of the periods because I want to treat those as actual periods, not the way grep normally treats them as, hey, match any character. It's not a big deal. You might get a little extra if you don't do this, but I'd like to show you the clean way to do it. So this will show you just the lines in your log files that are to or from that IP address. And just below that, you can see, for example, that that machine is making DNS requests. There's DNS queries or connections going from 10.0.0.238 to 75.75.75.75 port 53. That's Comcast's public DNS server. So you could make a guess that this machine might be on one of the Comcast networks. I can also look for particular protocols. I can say, show me every line that has HTTP in it. I put a \W in front and behind that, and that says I want to have white space in front of the letters HTTP and white space behind it. That's a tab or a space. So I don't need to care about what separator is being used in that file. For reference, it happens to be a tab in Zeek logs, but I don't have to care about which it is. I just say I want one or the other, both in front and behind. That means I won't also match HTTPS, assuming I'm just looking for HTTP. Now, one of the nice things about Zeek is that you're given an identifier for each conversation. So if you look back up to the first line of output near the top of the screen, I see the name of the file, the name of the Zeek sensor, the timestamp, and then there's this long random string. That's a unique identifier for this conversation. If I want more detail about this conversation, I can look for that identifier in all of the log files in this directory, saying, does anybody else have any more detail about this particular conversation? So down near the bottom, you've got 5 lines. One comes from a con log, Another comes from the files log, which are files that are being transferred in or out. And the last two come from the HTTP log, showing that there's an HTTP connection to or from that IP address. These are all related in a single connection. So now you can get more detail about that by using that unique identifier and looking for it through all of your files. You'll get all the detail that Zeek has. You might just want all the lines. No problem. If I want all the lines, I'm going to feed it into some other tool or save it to a file or send it off to somebody else, no problem. You can type zcat space asterisk.log.gz, and all of that stuff will come out of that command. In this case, we're feeding it back into less, but you might have some other tool that you want to send it to, no problem. If you want the file names included in the output, you can use zgrep space period, saying, I'm going to look for any character in any of my logs and send them all to output. The side effect is that the grep command normally wants to show you the name of the file where the data came from. So this is where you'll see on those last three lines of output, you see capture loss, blah, 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 log.gz. That tells you what file they came from. And this will help you narrow down whether this is something that came from, in which hour it came from, for example, or which log it came out. If you don't want the header lines, you just want to have the individual data lines, but you don't want those commented lines at the top. Apologies for the barking. You can throw the comment lines away with zgrep. Zgrep-v says, decompress these files. -v says, I've got stuff I want to throw away. So in this case, I want to throw away single quote, caret, pound, single quote. And the way to read that is I want to throw away any lines that have the pound character at the beginning of the line. So that caret says, only look for that pound character at the beginning of the line. If you see it there, I don't want it. Show me everything else. And this is where that you get all of those data lines, but you don't get the header lines. If you want to get rid of the file names as well, just add -h to the command. And just like so many other tools, if you want -v and -h together, you can use -vh. zgrep and grep will work with either form. And now you're just left with the data lines, no headers, no file names. I just want to see those. Zeek has a tool that has been distributed in a separate package for a long time that helps you find particular columns in the output. So if I care about one or two particular fields in these lines, but I don't want this whole long mess, I can ask for those with the Zeek Cut command. So let's give an example here. I can start off by spitting all of the lines to standard output with zcat con.asterisk.log.gz, and then I send those to the Zeek Cut command. With Zeek Cut, I tell it, here are the only two columns I care about, id.orig.h and id.response.h. id.orig.h is the originating IP address or host. id.resp_h is the responding host. So this gives me just the two IP addresses of the machines involved, but nothing else. And with this, I can look and see what patterns there are about which machines are talking with which. I might feed these into sort or grep or all kinds of other tools later, but this is how you pull that out. Zeek Cut is not included by default when you install the Zeek package. It's usually included in a package called Zeek-aux. So if you don't have this on your system right now, try using apt space install space Zeek-aux or yum space install space Zeek-aux. See if that's available. And if neither of those is available, you can get this from its actual repository Go to github.com/Zeek/Zeek-aux, and that package is there. They may have some recommendations on the easiest way to get it onto your system. You might also look up the name of your Linux distribution or some other Windows system or Mac OS and say, what's the best way to put this on there? It is included. Sorry, I'm not sure if it's included in Mac ports. I haven't looked. If you're using Bro, remember that Bro and Zeek are basically interchangeable brothers. They're just different names for the same tool. Bro is the old deprecated one. But if you have Bro-aux installed on your system, you'll have Bro-cut. And you can use them interchangeably in your commands. And in fact, you can make a symlink from one to the other. That works just fine. So what other things can we look for? Well, I can look for ports, for example. I might be interested to see if anybody's using, I believe 5353 is multicast DNS. Or link level multicast name resolution, LLMNR. I can't remember which. One's 5353, one's 5355. I'm sure that'll show up in Discord in just a minute with somebody who's got time to look that up. But I can look for that with zgrep space, the number of the port I care about, and I put a dot asterisk saying, I don't care what characters come in the middle between this and UDP. I want to see any lines where there's 5353 and UDP following it anywhere in the comm logs. And this will do that search. So that will show you all LLMNR or MDNS queries in your logs. I can look for it by protocol. I know that there's ICMP or TCP or UDP I want to see all of. I can look, we saw an example with HTTP in an earlier slide. So basically, you can look for anything on those lines as a piece of data of interest by just putting it after the zgrep command, and then you can narrow down that search if there are too many lines. What other files are available? Well, Zeek has somewhere around, I don't know, 15 or 20 different log files that it has available to you. Capture loss is a little bit of an oddity. It talks about whether packets are getting lost in the capture process. It's not the same as the rest, but it's certainly available if you want to see if packets are getting lost at the capture point. Con summary is a short summary of what's happened in that hour. Keith will actually be showing that in just a few minutes. So hold on just a second. We'll give you a live example. DNS are DNS queries and responses. Who's making DNS queries and who's answering? What was sent back? What are the low-level technical details? HTTP is about HTTP requests. And the nice part is that since HTTP is unencrypted, you may be able to see the host name that's being queried, the URL that's being queried, the user agent that shows up, and all the rest. For files that are being transferred in and out of the system in multiple protocols, files.log.gz will have that data. And if you want to see more about the SSL or TLS encryption, that's in ssl.log.gz. The file name has stayed the same, even though we generally work with TLS these days. They're brother and sister names for the same concept. SSL is deprecated, but TLS is what we use today. They just didn't want to change the file name. If you want to know more about the certificates being used to actually support that encryption, take a look at x509.log.gz, and those details will be in there. Zeek's website has details on these files and others. If you want to know about what's available, go ahead and take a look at those. That's it for me. If you got questions, go ahead and add them to Discord, and we'll chat about them later. I turn it over to my esteemed colleague, Keith.
Thank you, Bill. Yeah, that was great. That's good stuff. Yeah, I see there's a lot of back and forth on Discord, which is always good too, to kind of talk this out, and we all try to figure it out together. We're going to move on a little bit to, I guess, a different method of doing so, and using this awesome tool, which I'm going to throw a link into Discord. It's called THT which was created by Ethan Robish. For those that may not be familiar with the name, Ethan is an employee of Black Hills Information Security and Active Countermeasures. I'm not sure if he has a title, but he pretty much does a little bit of everything. In fact, he's responsible for a lot of the programming for Rita and AC Hunter. And he's been around a long time. In fact, there is, there's been, discussion that he was the first Black Hills Information Security employee. I guess there might be a little debate around that, but as they say in New England, he's just wicked smart. And you should really check out this tool. It's become my default tool for analyzing or searching through Zeek logs. It's really awesome. And here's just, I just put this slide in here. So if you get a copy of the slides, you have this. There is some documentation on THC and access to the cheat sheets, which is really good to have. What THT does is it takes a lot of the common command line commands that you would run, similar like what Bill was just showing, and it kind of wraps it up all in one place. And he's also added a lot of customization. And what it helps with is instead of having to craft like a 100 character long command string to apply a combination of commands to output what you need, it's been condensed into a lot of shorthand. And so to me, it's much easier to use. So for using THT, it's very simple, and you'll see on the GitHub page, there's just a one-line curl command that you run, installs it on a Linux box, and you just type THT at the command prompt, and it launches you into the THT shell. And as Bill was discussing, as far as where your Zeek logs are, the default with Zeek is going to be an opt Zeek logs, and that's going to show all of the Zeek logs, which the directories are going to be created by the date. So if you did want to go into a directory to look just by date, then just go into that particular dated directory in order to work in that directory. Then you can also define your search or what logs you're looking at by the command string I'm showing below. So when you're in THT, when you launch into the THT shell, one thing that I just want to mention, that when you're in the THT shell, it prepends the path with the host parent directory. And I just mentioned that that way when you're changing directories in the THT shell, you're just a little more aware of the navigation there, that you do have the parent directory of host. And if you notice the string I have below that that's where you can define your actual date range. So if you put yourself in the working directory of just opt Zeek logs, or whatever your directory happens to be where all your Zeek logs are, then you can use this parameter to define what date range you actually want to look at or analyze. And in this case, if we kind of break it down, the FD is the find command. DNS is just saying we want to look in the DNS logs, and then we define our date range. And then we pipe it through a filter, and that filter in this case is we're just looking for anything in DNS with the domain of Microsoft.com. And then I'm just going to kind of run through a few examples of using THT. This is by no means like a guide on how to use it, all the different things you can do, because if you do check it out and start working with it and go through it, it's pretty much unlimited, the things you can do and the different ways you can display the data and what you want to see and what you don't. And the first one is we're just going to look at the connections. And this is in the con files, but we're going to just look at a simple con summary. And if you notice at the top, you can see my current working directory is host opt Zeek logs, and I'm in an actual data directory, which yes, I know is a bit old, but it doesn't have a lot of traffic. It's just one of my malware labs. So it has, I think, 6 or 7 Windows boxes in it. It doesn't really generate a lot of traffic, but to me, it makes it a little more useful to display this. So we're not having to look at so much data. But you can see it's a very simple string. I'm just commanding filter pipe con summary. And this is going to show all the connections from this date. So it's a 24-hour period. And as you see, it's given us a summary of all the connections. So within this 24-hour period, we have just a little over 45,000 connections and the total amount of data that was transferred during these connections. And it'll break it down by the percentage of traffic. So here's our internal host. Here's our external destinations. And it also lists, by percentage of which services were used, protocols, and the states as well as ports. And I do want to mention that just because these are in columns next to each other, none of these actually align. Okay, so these are all just separate chunks of data here. So, don't look at it like this is going there and so forth. And then also it will show the amount of data. So, which machine is actually pushing the most data through the network and so forth. So just an example, we're just kind of look here and we can actually see by doing this full con summary, we can see like our top talkers. In this case, it's an internal host that ends in .51. It has 26.2% of the traffic. And when we look at this, we can also see on the destinations, the percentage of traffic that was going to these destinations. And in this case, this largest one here, this is actually a C2 channel that I had set up. This one here is just an open DNS. And we have some other examples in here. So now we know that the .51 is our top talker. So now we can just break it down and we can filter just on that host IP and also do con summary. And that shows us just the traffic that was going to and from this .51 address. And then here we can see again our destinations. That's my C2 channel. So I had the majority of the traffic. Again, that's just an open DNS server. This one here, I actually had already researched that. That's Microsoft domain. But one thing to point out, and what kind of helps me is when I'm kind of analyzing this, is it's showing you both the total connections and the amount of data that's transferred. And it allows you to just kind of do some quick analysis. Like in this case, I see this 104 that ends in .191 had 1.8% of the connection traffic. However, it had 16 or 17.5% of the data transfer. So to me, that it just looks a bit odd. That doesn't mean that something's wrong. It just allows you to view the data in a way that you can kind of drill down on it a little bit. So in this case, we kind of want to take a closer look at the communications that were going on between these two. That way we can see just the counts just on the communication between these two instead of being mixed in with everything else. In this case, we see it was 216 connections over a 24-hour period. So if we actually did think that, okay, this looks kind of fishy to me, I'm not sure what's going on. I see that this internal host is talking to this internal host, but I may want to know, okay, I see this one's talking to this external host, but is this external host having any conversations with any of my other internal systems? And this may give me an idea of, okay, this may be normal. I mean, if it's spread across all my systems, or it may be a single outlier. And if so, it may be a little more something we want to look into since it's so unique. So what I did, I just run filter just on this particular external IP, and again, con summary. And it shows that 100% of the traffic is actually just this one internal host. Now, I did run this down. It's not actually malicious. We can also run it through our DNS logs to see, okay, this IP that we're not sure of, does it show up in any kind of DNS logs? Is it associated with a domain that we've seen in Zeek? And so what I've done here is again, I did filter in the space ---- DNS because we're looking through DNS, put my IP in question, my destination IP, and then I'm piping it and then I'm chopping, which is very similar like Zeek Cut. It's a very similar tool. But what we're doing is we're going to chop these DNS records to where we just want to see the query that was made for this IP, and we want to see any answers that were returned. And after that, I'm going to pipe it through MFO. And MFO is the most frequent occurrence. And that way, instead of it printing out a long string of lines of every entry that it sees, if you pipe it through the most frequent occurrence, it's going to show you the most occurrences first, and it'll actually number how many times that has taken place, and it'll give you a list in that fashion. And you can see that that running this command, I got back just a command prompt, so there was no results, which just shows me, at least within the data we have within this 24-hour period, there was no domain associated with this. So it appears to be a direct connection between our internal host and the external host, which sometimes, again, can be another indicator of compromise. It doesn't mean it's bad. It's just that in general, a lot of the traffic that's going to be taking place, say over HTTPS, is going to be associated with some form of domain. But again, like I said, I looked it up, and it actually was a Microsoft domain, and it was legitimate traffic. So if we look at another one that was in our con summary under that same host, and we run that through this same command, so we're looking at the DNS logs, but we're looking at this IP address. Again, we're chopping it by the query and what answers were returned, and then piping it through the most frequent occurrence. Now we can see that 498 times, actually, that this IP is associated with this actual domain. So this full domain was what was queried by our internal host. And when it was queried to the DNS server, it returned the answer of this IP. So this just kind of gives you an idea of how you can kind of just sift through this and kind of glean the information that you're looking for. And again, working with DNS is, you can see at the top, that's what we just did. We ran that IP because we knew the IP address. So we ran that IP address through our command, looking for the DNS query, which gave us the domain actually associated with that IP. But you can also reverse that. Is if you don't know the IP, but you know the domain, you can reverse that as I'm shown below. Again, you just filter through DNS, put the domain, and just pipe it through, just chop just the answers. And then you'll see actually what the DNS server answered as far as the lookup of that domain. And you can also run to show all the internal host or source IP address that queried a particular domain. In this case, I ran the example from Microsoft.com. So we're going through our DNS logs. We're looking for Microsoft.com. We're going to pipe it through CHOP. And in this case, we're using one of the Zeek fields, which is the ID.origin_host. So that's what we're only concerned with, just the origin host. And again, we're piping it through the most frequent occurrence, which is going to show us the most results at the top, and it will goes up for us. So in this case, we can see out of all of our internal hosts, again, like I said, this is a very small network. These are all of them. Out of all of our internal hosts, all of them actually have resolved to Microsoft.com in one fashion or another. And it counts how many times those have been accessed by our internal host. This is a string that I use quite often when threat hunting networks. In fact, it's one of the first things I do to get kind of a feel of the landscape of the network. And it's also very useful to find, as I put in here, undesirable domains. So in other words, if you're on a corporate network and you have certain policies that, say, for an example, the company frowns on, a lot of social media usage, like Facebook and Twitter and things of that nature, where they're not necessarily blocked. So you'll be able to get through the firewall. It's just that it's probably not something that the company would want any employee spending 5 or 6 hours a day on Facebook, or other maybe restricted, like, adult domains, things of that nature. You can use this through your DNS logs to just search through there for particular domains. and it'll show you which internal hosts are looking up the resources at those domains. Another thing this can be very useful for is, let's say if you have some type of security alert, or you're reading something that was put out by like Krebs on Security or some of the security portal, or even ourselves, talking about a new or current attack or malicious actors, and it's been exposed that they're using particular domains for their C2 channels or for communications, say whatever that is, like evil.com, then you can simply just query your DNS logs directly as shown through Zeek to see if any of your internal resources are even reaching out to those domains. So it makes it quick and easy to kind of pull that out quickly. And the other thing, and this is again something that I tend to do on most networks, is I want to see are any, and again, this applies more so to corporate networks that will generally have an internal DNS resolver that will handle any DNS queries and answers. And there's a lot of reasons for that. Of course, we won't get into, but it gives that company a lot of control over DNS traffic and who's going where, and also for logging purposes. So you want to make sure that every resource that's within your internal network, all of their traffic goes through that internal DNS resolver, so you don't get that type of what I put on here is a DNS leakage, which basically what we're looking for is we're looking for any devices, machines, or hosts that may be misconfigured in a way to where that particular machine is using another DNS service, like a Google DNS or Cloudflare or OpenDNS, and bypassing the internal DNS resolver, which may seem like, oh, well, that doesn't happen. And I must admit, I think I've seen this on just about every network I've analyzed, is there's always a subset of machines that are going directly to Google DNS or directly to Cloudflare. And I'm sure there's many other ways to actually search for this, but I just do a simple DNS search on ARPA just because it's a very common request. It's something almost all programs machines are going to reach out to look for. So to me, it just kind of gives me a very quick look. And you're going to see here actually that, like in my command string, I'm searching DNS records for ARPA, and then I'm piping that, I'm chopping it by the response host in the query that was made. And then again, I'm piping through a most frequent occurrence. So you can see the queries, they're all ARPA queries. All the ARPA queries, and in this case, they're all using OpenDNS because I have my malware lab set up for everything to use OpenDNS. But to do this like on any other network, you may be kind of surprised to see how many of these are actually not using your defined DNS. So that's just something to look out for. But it's very easy to do here. As you probably notice, if anyone, like Bill before me, like, Chris, who's on this webcast as well, we're so used to having to craft these long commands to output what we need. And this is really the power of THT, is it gives you a lot of shorthand. And to me, it's a little more plain English. And I also think that those that are here that may be new to this, that looking at what we're looking at now may be a little less scary. Because I must admit, like when I first got into doing this myself, when I saw some of these command strings to search through logs and some of the math that was involved in it, literally gave me migraines. So I mean, it's fine when you understand it, but when you get into like regex expressions and so forth, it does take a bit of knowledge to do that, which, we need that knowledge and that's fine. But what I'm getting at is when you're starting out, these tools here will help you greatly. to be able to pull out, kind of the data you're looking for without having to spend the next 2 years learning how to do regex. So,
and Keith, if I might comment, that Ethan, the author of this package, absolutely is the kind of person who will make 12-mile long queries on the command line without
yes.
without a second thought. He's absolutely able to do these, but
Yes.
the point is he does this so often that it just makes sense to come up with the shortened versions that go into THT
Yep.
to make his day go faster and to make his searches more fluid and to not have to think about how you structure these long command lines. Maybe there are times when you have to fall back on it, but this is a convenience feature that isn't limited to just new users. This is a convenience feature for anybody who does this type of work.
Yeah. Yeah. And that's a great point. And you're exactly right. I mean, because the same math is happening here, but in this case, using THT, the math is happening in the background. Whereas when you're just fully working on, just direct command line, I mean, the math is in your face. And, like I say, I believe you really still need to understand it. I mean, to really grasp all the concepts. But this just, at least to me, it makes it so much simpler. And like I said, this has actually quickly became my default tool. This is how I kind of go through Zeek logs. And I just happened to actually notice a comment on Discord that I'd like to comment on by Analog Kid. And he's asking the question, says, you're saying to block those DNS servers? Oh, he may be responding to someone else's.
I think there was
but
an
if someone
earlier
else
question
is asking
about
that question, does this mean to block these DNS? That's not at all what I'm saying is none of these DNS servers, like these external DNS servers, are bad in any way or they should be blocked. What I'm getting at is if you configure all of your machines to use a particular DNS service, which in my example, I'm talking about like an internal DNS resolver. So that's, before it leaves your environment, then you want to make sure that all of your internal systems are using that DNS server that you define. So if you have that all set and everything looks great now, and then maybe a subcontractor, a contractor moves in, 20 window boxes and, sets them all up correctly as far as your security standards and so forth. However, they may not have configured those systems to use the correct DNS server. And this is a kind of a quick way to kind of pull out which systems may be misconfigured.
100%. Absolutely. Hey, we've got some thank yous, by the way, I think on the next slide. Thank you to everybody, for all of you for joining us today. Ethan did a wonderful job of putting together THT. He's going to make all of our lives easier. Shelby, who's unfortunately not here today, but sort of set this up along with Jason and Deb. Thank you all. We've got one more tool that I might cover briefly because we've got a few minutes left. We still have time for questions.
Oh, please do, because I know what you're talking about.
Yeah. So if you could go ahead
through this out yesterday, and it was freaking awesome to me.
Yeah.
And you could tell how much a geek I am because when he sent it over, I kind of looked at it and I was like, all right. And I looked at it a little more. I was like, oh man, this is great. I can't wait to use it. I got all excited.
That's great. Go ahead and move to the next slide, Keith. So this is from Chris Brenton, who is talking about a quick and easy way to pull out just a couple of things from the connection logs and the SSL logs. And so if you make a file called IP-check, put it in a directory where it can be executed. Usually I put it into the bin directory off of my home directory on Linux or Mac OS. And once you put in the 3 lines that are listed on the slide, you'll need to save that and exit and then make it executable. Linux by default won't execute something unless you say it needs to be executable. So the command to do that is that chmod 755 and then the name of the file. You'll need one additional tool. We've talked about Zeek Cut already today. If you don't have that already on your system, you'll want to install that. The package for that is usually called Zeek-aux if your operating system has it as an available package. And if not, You can go back to that GitHub link that I showed you earlier and compile it yourself and put it in an executable directory. That's all the setup. Let's give you a couple examples of how to use IP check. IP check will let you look in the current directory for logs. So I'm going to go directly to today's log directory, opzeek logs 2022-09-22. And if I run ipcheck init.itunes.apple.com, I can get all of the lines in the connection and the, I believe it was SSL logs. No, DNS logs. Can you go back one slide, Keith? This is how bad my memory is. It is SSL. My apologies. Great. So go ahead to the next slide, please. IP check will look specifically in the IP and the SSL logs for a host name or an IP address. So we've already talked about looking in the con logs and the DNS logs for interesting stuff. Why would we look in the SSL logs? Well, if you look at that command that we put into that shell script earlier, we're looking at not only can you tell me about this particular host name, but we're also asking for the certificate status. Is this okay? If there's an okay on the line, that means that this certificate is valid, it's signed, it's associated with this domain correctly. All of those things are good. But we also check to say, is this a host name, but the certificate doesn't match, or it isn't signed, or it's self-signed? Zeek will report on a lot of those errors. So this is where looking at the certificate status can teach us about whether this traffic really should be happening or not. We're looking for the okay string, and if we find something that isn't okay, now we have to go and say, why is that host coming up odd? One example is when you have Windows systems on a local LAN. I believe the setup for the Windows system will try to make a fake certificate for that host, but it's not one that's signed. It's not valid. And so you'll get unable to verify local issuer certificates, something along those lines. That just may be a sign that you've got Windows systems on the network where the certificate isn't signed. This type of search, just like so many of the tools that we showed earlier, can take either a full IP address or a fragment of it. So if you just want to look at the hosts in your network that have on your LAN, you can simply put in the first couple of octets that match all of those hosts and do a search for it. So for example, I had ess.apple.com. There's some hosts underneath that have invalid certificate, and I get unable to get local issuer certificate in the status field. I couldn't tell you why ess.apple.com for some reason seems to run into this problem, but that seems to be a common one. Because of the way that script is designed, it will read both compressed and uncompressed logs. So it will pull in whatever you have. That means that you can run this both in the daily directories for Zeek, but you can also run it in the current directory for the logs that are actively being processed right now but are not yet compressed. Both work. So Keith, we're all set with that. Do you want to back up 2 slides and do a thank you? And then perhaps the other people on this call can come in and give us some questions that have seemed relevant or need some help.
Well, first, well done.
Good job. Yeah, thank you. Thank you, Bill. Yeah, that was awesome.
Yeah.
And Keith too.
So far, I'm not seeing any questions except for this is similar to Security Onion's dashboard. Any relation?
The what?
Security Onion has a dashboard. They wanted to know if there was any relation to.
I guess somewhat, but this is going down. We're just searching the Zeek logs directly. But Security Onion is such a huge tool platform. I'm not sure exactly. I guess what the question is, but
so does IP check support CIDR?
In the sense that you can type a fraction of the IP address that you're looking for, yes. CIDR is where you give a specific subnet. So I might say, give me all of the addresses under 10.0/16, saying, show me all of the addresses only in that particular subnet. IP check will not handle CIDR blocks, but I can just type 10.0 and say, give me all of the addresses that start with that. So it's not quite what you asked for, but it gets partway there. And then you can narrow those results down better.
Question, will a link of the recording be sent out to the group? Generally not. What we do is we just post everything to the YouTube channel. So if you go to youtube.com/active-countermeasures, you'll be able to watch this recording and all recordings of all past webcasts, including like the 6-hour-long threat hunting trainings and we have a new one coming up in
October 2nd, I think, is a Tuesday.
Yes.
Pardon, October 4th.
October 4th.
Cannot scroll that fast in my calendar. There we go. That one is going to be from 10:30 to 5 p.m. Eastern time. It's a free class. If you're interested in joining up on that, perhaps somebody could post that in the Discord channel. Please join us. We would love to share this. It's got hands-on labs. Our esteemed Chris Brenton will be teaching that one, and we'll be on there answering lots of questions.
Yep. I also dropped the slides into Zoom in the chat. So if you are not on Discord, for whatever reason, you can grab the slides from there.
Wonderful. Thank you.
There was also a couple of folks were asking for example Zeek logs they can use to play around and kind of, I was telling folks, if this is new to you, wait till the video gets released, watch it again, pause when you need to. I put in the content channel some Zeek logs that you can go in and you can play around with. There's a couple of C2 channels in there. So part of this can be, hey, can you find them?
Nice.
Right.
Yeah, it's just kind of along those lines. I just kind of wanted to mention also that, what we're talking about here is like doing an investigation through your Zeek logs, being able to pull out the data that you want to look at in Zeek logs, and it can be used for threat hunting to a point. So if it were like a network like I just showed you in my example, which is very small, I think it had 6 or 7 hosts in it, you could use these tools that we just talked about to threat hunt that network. But as soon as you get into like any volume of traffic, I don't believe this is the way to threat hunt.
Rita.
Yeah, you need a tool similar like what Chris is saying, like Rita or AC Hunter or many of the other vendors that are out there that make tools that will actually analyze your network traffic and data to pull out threats. At least this is my opinion, but I think if you're even a small shop with, say, like 100 Windows boxes, and this was your solution for threat hunting your environment, you're going to be spending a lot of time just chasing false positives, and you're probably not going to get anywhere.
And that really gets back to our original idea for this webcast, is that you're hopefully using a tool that's appropriate for the task. The techniques that we've talked about here today shouldn't be your primary way of identifying problems on especially a large network or where you are paid for this task, and this is your full-time job. This is how you get more detail when your high-level tools simply don't have the detail you need, or you can't understand what they're telling you. You have a way to get down lower into the process to say, give me some more detail so I can learn about this.
Exactly.
Hey, thank you, everybody. We appreciate your time. Thank you for your questions and your interest. We've got more webcasts coming up. I don't know what our next one is. Apologies. I should know the answer to that, but I don't. Jason, do you have any others that are coming up that people can sign up for?
So far, the only one scheduled is the October 4th 6-hour threat hunting with Chris Brenton. After that, we'll take a look at the rest of the year and see what's available.
And if you haven't already signed up, we have Wild West Hacking Fest coming up in Deadwood, South Dakota. We would love to see you there if you can make it in person. We also have the option to attend virtually. So if flights or masks are just not your thing right now, we would love to have you take part even from home. There's a lot of good talks and presentations going on, and it's just a wonderful time to get together with other like-minded technical people. Let's call them that. Thank you, everybody.
Bill,
Yes.
any final words?
We're all set. Thank you much.
Keith, any final words?
Just thank you all for being here and joining us. And hopefully you find some of this stuff very useful and it will help you out.
Well, everyone, thank you so much for joining us for this Active Countermeasures webcast. We do this all the time. We like to share our knowledge because if you learn more about this, then you'll get better at this. And then the bad guys will have to get better at this. And so we'll see you all next time. Bye-bye.
Bye.